Hi, welcome to Tech Tasters. In today's bite-sized bite, I want to talk to you about what AI is. However, before I do that, I think it's important to talk to you about what AI does. AI models are designed to solve complex problems. They can tackle issues by analyzing vast amounts of data while simultaneously considering multiple variables. This allows them to find solutions to problems that might be too difficult or time-consuming for humans to solve efficiently. One of the most fascinating aspects of AI is its ability to learn and improve its own performance over time. Through techniques like machine learning, AI systems can analyze their results, identify areas for improvement, and then adjust their algorithms accordingly. Pattern recognition is one of the most fundamental principles of AI. Once the algorithms have been properly adjusted, AI can then recognize and categorize new data for proper processing. It excels at identifying patterns and trends that might be invisible to the human eye. This makes it invaluable in fields like medical diagnosis, financial forecasting, and scientific research. After analyzing enough historical data and processing the current input, AI can start to make predictions based on the patterns it's identified. This process is called inference. That's just a churched-up way of saying it makes surprisingly accurate guesses. This predictive power is being harnessed in areas ranging from weather forecasting to stock market analysis or predicting the next word in your email or text message. But the pinnacle of enhancement is when we allow AI to make its own decisions. Once we have enough confidence in the AI's predictions, we can allow advanced systems to make decisions independently based on their analysis of the current data and predefined objectives. This autonomy allows the AI and self-driving car to determine whether it needs to apply the brakes or the gas. It can decide whether to use a blinker or change lanes, or when to stop at a stoplight or when to turn. Now that I've summarized what AI can do, hopefully this definition might make a little more sense. AI is achieved when a computer can execute a task that typically requires human intelligence. An example might be a virtual assistant, things like Siri, Alexa, or Google Home. These things can not only tell you the time of day or tell you what meetings are on your calendar, they can also turn off lights in your house. Spam filters are another good example. They'll look at the content of the message, the sender, and the origin of the message to determine if you should even see the message in the first place. Amazon product recommendations will use your past purchases, recent browsing history, your geography, and even the time of year to recommend different types of products you might enjoy. Facial recognition not only uses AI to identify your features on your face, but to make adjustments for things like if you're wearing reading glasses or sunglasses, or if you have facial hair or not. It will still be able to detect who you are. Fraud detection's been helped tremendously with AI. In milliseconds, it can determine if a transaction is fraudulent, saving a potential hassle for both you and the credit card company. I've already talked about autonomous vehicles. Manufacturers like Tesla and Waymo are producing these vehicles that have a high degree of sophistication with AI. If you were to take one for a drive, I think you might be surprised at how well it does. With that simple understanding of what AI is and what it does, I want to finish by telling you how it's built. The simplest way I can think of to explain the process is with the term called machine learning. It's basically a way of training computers the same way that we learn as humans, by repetition and correction. Just like homework from a math teacher, the problems might be different, but the topic or principle it's being taught is the same. That's what we're doing with AI, except instead of 10 to 15 math problems, its training loop is performed trillions of times. That's 10 to the 15th power, or 1,000 billion, if that makes it easier for you to understand. That much training requires a lot of data. So much, in fact, that it's pretty difficult to comprehend. The most recent large language modules have been trained on a dataset so large that if you printed it out on 8.5 by 11 paper, the stack would be over 400 miles high. That's like stacking Mount Everest 67 times. It also puts you 2/3 of the way to the International Space Station. I'm sure you probably realize it takes a lot of computing power to get through that data. But when we talk about computing power, we're not talking about CPUs, which are the traditional way that we gauge computer speed. Common manufacturer of these would be Intel and AMD. AI actually thrives using GPUs, or the graphical processing chips. Right now, the most popular AI GPUs are built by NVIDIA. Their chips are so vital to current AI development that NVIDIA recently became the most valuable company in the world. I'll do another video soon explaining why GPUs are preferred in AI over CPUs, but a quick answer is that they're better at parallel processing, they can scale much larger in clusters, and the chips have a special processing language built directly into them for improved speed. Anyway, I hope that information helps you understand AI just a bit better. Thanks for joining us for this bite-sized bite. I'll see you next time.